problem has a lot of layers to it that you might not notice initially. It says a plane is flying at an elevation of 10,000 meters and a speed of 300 kilometers per hour. Notice here we have meters, here we have kilometers per hour, and then here it's asking us for to the nearest minute. So there's going to be some kind of maybe a little bit of yucky stuff that we're going to have to take care of in these processes, but not too difficult. So first of all, let's just draw a little sketch. Here's my airplane. With my mad drawing skills here. All right, and we have the pilot here, and he sees a lake at an angle of depression. So the pilot's looking down here at the lake. Here's the lake, right? Beautiful lake. And it says the angle of depression is 60 degrees. So remember, you've got this imaginary horizontal line, right? So here's the 60 degrees. That's the angle of depression. Now, how high is the plane up in the sky? Looks like he's 10,000 meters up. So that's where this is going to come into play. All right? Now, if we know this is 10,000 meters, because this is in kilometers, I'm going to suggest that we change this to this altitude to kilometers, okay? Which means we could divide, if we're going from 10,000 meters, okay, into kilometers, right? 1,000 meters is 1 kilometer. There's the actual conversion factor, right? That means we can cancel 3 of the zeros. So that's 10 kilometers. I hope you can see that. This is 10 kilometers, right? Okay, so essentially it's saying in how much time to the nearest minute will the plane be directly over the lake. Well, look, people, what we have to figure out is how long is it going to take him to fly right here. So what is this distance? Because remember, rate times time equals distance. All right, that's what we're trying to find out, the time. We already know the rate, we know how fast the plane is flying. So if we know how fast the plane is flying and we know the distance, we can figure out the time. All right, so let's do that. And which trig function do we need to use? Well, do you see that we have the opposite over the adjacent? So let's go with the tangent of 60 degrees is equal to 10 over our distance. We'll just call this D here, okay? So if you have that distance, essentially what we're going to do here is take, you've done this often enough, I'm hoping you get this here, but you see we have D tangent of 60 is equal to 10, right? So that means we're dividing both sides by 10 if you're showing your steps, which I suppose you should be, because you know I keep telling you to do that. So D is equal to 10 divided by the tangent of 60 degrees, which I show to be 5.77, approximately, right? So 5.77. Now, I'm going to leave this in my calculator so that I can not lose any accuracy. In fact, I'm going to store it in my calculator so I've got it. And this is in kilometers, right? Okay, so now let's come over here to this equation, and we know that we know that the rate is 300 kilometers per hour, but we need it in kilometers per minute, right? So we have another conversion factor that we're going to have to take care of. Let me just change that color so you don't get confused about what's going on here. We have 300 kilometers per hour, and we're converting that to kilometers per minute. So we have our conversion factor is 1 hour over 60 minutes. I'm using these conversion factors because I want the hours to cancel. So now I have 300 divided by 60. If I cancel those zeros, I get 30 divided by 6, which means he is going 5 kilometers per minute. Okay? All right, so that's very helpful. Now let's see what we're solving for. We're solving for time, right? So if we want to know what the time is, we can divide both sides of this equation by r, which gives us time is equal to the distance divided by the rate. So our distance, we already know, is 5.77 kilometers divided by 5 kilometers per minute. Kilometers per minute. All right, so now, look, people, this is actually not that hard. If you take that 5.77 that you have in your calculator, divide it by 5, you get 1.15. 1.15 minutes, but it says to the nearest minute, so we're going to say it's approximately 1 minute that it's going to take him to fly that far. All right, just to recap a few things that we noticed at the beginning that are pretty critical. Meters, minutes, kilometers per hour, and so recognizing the kind of the fastest way, or the way that's going to leave you with the least confusion at the end. I changed this to kilometers because that was nice and easy transition. I changed this to kilometers per minute because I wanted this in minutes. So those are some ways that you can make your life a little easier.